Good morning. Step into my meth lab. We're making some iron trichloride, or iron 3 chloride, whatever you want to call it. Why? Because I got nothing better to do on a Saturday morning, and because it's a compound that is useful for at least a couple of things, including but not limited to etching steel and testing for the presence of the mycotoxin orellanine, which is exactly what I'm planning on using it for, if I even remember to do that come autumn. Producing iron trichloride is usually a fairly simple and straightforward process. One way of doing it is by heating up some iron and dipping it into a chlorine atmosphere. Very simple if you have the right equipment for such a process, which I don't, so I'll just end up gassing myself if I try to produce any sizable amount this way. But I will show it regardless because it is somewhat interesting. The process, not the gassing. Although it would make for a very accurate reenactment of the Battle of the Somme. To generate the chlorine, I'll just crush up some trichloroisocyanuric acid pool tablets and dissolve them in some dilute hydrochloric acid. This is by far the easiest way of producing diatomic chlorine on the fly. No fancy electrochemistry up in this bitch. I'll start by diluting the acid. The proper way of diluting an acid with water is by adding the acid to the water, and not the other way around. Because legend has it that some vague shit will happen if the water is added to the acid. I say vague because chemistry teachers never really say exactly what's gonna happen. But that's not good enough. What could happen if the water is added to the acid is that it could start bubbling like a motherfucker, get out of control, or in some cases, explode. Reactions like those need a very specific set of circumstances to happen. And nothing is likely to happen to hydrochloric acid at standard room temperature. But it's a good habit to get into, because in this case, the worst case scenario can be really fucking bad. I'll be using a tired old piece of steel wire as my iron source, so I'll just let that simmer on low heat while I go fill a bucket with chlorine. And immediately everything smells like a fucking war crime. But there's your chlorine, your Cl2. God damn. When doing it this way, the majority of the iron trichloride is released in the form of this thick, brownish yellow smoke which needs to be captured. And that's why this route is a bit shit when there's a serious lack of any proper glassware. But at least it looks cool. Because of the white paper, you can even see how the chlorine at the bottom of the bucket is being consumed. That said, however, some of the trichloride will form directly on the iron source. Keyword is some. I'm not expecting anything, really. But let's take a look before I move on to the route that actually works. Just take the steel wire and mush it up a bit, and you're left with this pile of slag. This is primarily slag that formed as a result of the iron reacting with oxygen when it was heated, and it's not the final yield. It's actually not even close. This soak in chlorine method will only produce anhydrous iron trichloride, which has a color scheme that blends in really well with the pile of slag you see on screen right now, unlike the hexahydrate. But if it's exposed to water, it should produce a golden yellow aqueous solution of iron trichloride. There's a minute change in color. As predicted, this sample doesn't have much of anything in it. So let me just dump the whole fucking thing in and let it sit for a while before I expose it to an alkaline solution. Ammonium hydroxide, to be exact, to verify the presence of iron trichloride. As a side note, sodium hydroxide can also be used for this. Well, it has a stronger color than the first potion, but it's still far too sad and rusty looking. You won't believe what happened next. Nor do I, honestly. I don't know exactly what's going on here, but I can tell you this much. It's not supposed to be fucking blue. Or green. Time to move on to the route that actually works. If you were to take that same steel wire and let it stew in some concentrated hydrochloric acid for a while, it'll produce these lovely little greenish-blue crystals. This is iron dichloride. It's more or less useless on its own, but it can be converted into iron trichloride with some motivation. Motivation in the form of trichloroisocyanuric acid. It's all about getting that last chlorine atom to attach itself to the iron dichloride molecule. And this is done by dissolving the trichloroisocyanuric acid in water. It doesn't dissolve that readily, but with some encouragement, it does. And then adding the dichloride crystals. As you can see, it doesn't take long for the solution to take on that golden yellow color we've been looking for the whole time. But how does it react with the ammonium hydroxide? If it's blue or green again, I'm gonna have an existential crisis. And this time it has the correct reddish-brown color. This is indeed an aqueous solution of iron trichloride, FeCl3. Crisis averted, I guess?